and can hear me. Like I said, if you have any trouble, just add a comment and we can try and get it sorted. So thanks to everyone joining today for our Datamine Discover mobile webinar. My name is Lawrence Cornier. I'm the business lead for Datamine Discover in Africa, and I'm going to take you through our latest release with the focus being on Discover Mobile. I wonder if I should undock this, probably. Let me just see. Uh, okay, there we go. All right, so let's get right started. Um, so Discover Mobile can be defined as a field data collection tool that is closely integrated with Discover Desktop. Now, there's a number of field apps available out there. You can get them fairly cheap, but I believe the big advantage of Discover is the ability one has to integrate the files and workspaces on your desktop onto your mobile phone. And this gives you the ability to take your data into the field, navigate to it, capture data into tables you set up, and thereafter transfer it back to your desktop. So it really creates a streamlined flow of data. And it's a great way to keep your files clean. You're not dealing with millions of different files and a bunch of CSVs. So the developers have come up with a very easy way of exporting it from your desktop as one file, namely a geo package. Uh, but I'll get into more detail with regards to that in a bit. So currently, the Discover mobile app is just available on Android for Android OS 6 to 8. There was a few reasons behind that. Mainly, it's a bigger market and less of a barrier to entry. But we should have an iOS version out by the end of the year. I think one of the other reasons was also Android phones are generally much cheaper than their Apple counterparts. And therefore, we brought out the Android version first, but Apple users do not fear we will have an iOS version out later this year. So the app can be downloaded for free from the Google Play Store. And that leads us to our next slide, which is the licensing behind Discover Mobile. Now, as I said, anyone can download it, but the app will only work with a project that was created in the Discover 2019 desktop program, which I will demonstrate shortly. Now, the Discover Mobile portion on the desktop will be available to anyone that has a maintained version of Discover. Therefore, you don't have to pay extra. It's not a separate product. And if your license is maintained, you can use the app. So let's have a quick look at some of the user benefits. With the app, a main advantage is really it solves the problem of going from office to field and back to office. Like I was saying, that round trip that the data makes, we created a workflow that has made the process really simple and easy. Firstly, you can take all of your GIS data from desktop to field. This includes your grids, such as your topos or MaxSAS grids. You can take your images, vector data, such as pointers, liners, and polygons, together with all the metadata. And I think the one advantage is you can then dynamically see where you are with relation to your data. So for instance, if you want to take an old geological map into the field, you can see where you are in relation to it, and this can help to aid with your observations in the field. Similarly, all your vector data, like your points and polygons, together with the metadata. So for example, if you're in the field and you got an old soil survey, you can interrogate it, see what the values are, and see where you are in relation to it. But we don't only want to take historic data. We, of course, want to capture new field data in the field as well. So you'll be able to collect point and line data in the field, capture it together with attributes. You can add images and photos, um, or you can record a track of the route you walked. Um, and it will really be streamlined by the use of drop-down lists or pick lists that you can set up on your computer, and it will make data capture a lot easier in the field. You don't want to be wasting time in the field typing out names, so it really speeds things up, and it also ensures consistency in the way you use the names and the spelling. Some of the other features are the waypoint finder. So let's say you have a soil sampling grid and you want to navigate to each point. You can make use of this tool. It helps you navigate around it. Also, I think most importantly, seeing that the bulk of our clients are geologists that work in remote areas, the app is built to work in an offline environment. So therefore, all the files can work offline, and you also have the ability to cache the Google base maps when you are in a good Wi-Fi zone, for instance, and then you take them to the field in an offline mode. So after field trips, you can quickly and seamlessly merge it back to the desktop, and the Discover Mobile project can also be distributed to a number of different mobiles. So if you have a team of samplers, guys doing mapping, you can distribute the project out to your team, and all the validation rules and drop downs will be available to them. So this is the workflow or the data flow. As mentioned, I think the biggest benefit is this whole streamlined process, going from office to field and back to office seamlessly without any clunky file conversions and other similar hiccups. So the way the data flow starts in a Discover Mobile project will be with your source data. This could be a SQL database such as Fusion or Acquire, or maybe Access tables. And you might have large enterprise like regional DTMs of, say, a state or a province. And a lot of this source data will be read only. But of course, we want to go into the field and capture into it and make it writable to some of these source files. So what we do is we create a mobile project on our Discover desktop. We can create a workspace with all the source data, and then in the mobile project, we clip out the data that we need. And we can create a copy of the source that will be read and writable. So let's say, for example, you have a DTM or a topo of an entire province, and you just want to clip the portion that you're interested in and put all the data in a common projection to make it easier to handle and easier to work with. It will also add all this metadata to your project data, and if you check it back in, the source data will know what changed and update the source files. So this also helps you to integrate back with the source data when you get back from the field. Okay, so we've checked out our source data. We created a mobile project. We've got a clipped data set, all in the same projection. And the next step is we want to export this to our mobile device. Now, there's a few ways we can do this as well. This project might have 20 or 30 odd files in it, different formats. You know, you got your vectors, your grids, your images, and we don't want to get stuck with different file types. Therefore, we export it all as one file, namely a geo package. This makes it a lot easier because there's only one file that you need to get onto your mobile device and back onto your desktop once you're done in the field. On top of that, the geo package is really a fantastic file format architecturally. For instance, it will automatically tile your grid images, and therefore the speed with which you can visualize and pan and zoom is increased significantly. The other cool thing about the GeoPackage is that you can take photos in the field and it will store it in the GeoPackage to a specific folder. And when you extract it back in MapInfo, it will dump the photos in a specific folder, and you don't need to go into your device and get the photos. It's all automatically transferred. So the next step, after you put the project on your phone and you're able to look at your data, um, we're collecting data into the tables that you set up with the different pick lists and drop downs. Eventually, when you're done, you want to export it back to your desktop. And this can be done either by exporting it to some kind of cloud format like Dropbox, or you could just manually put it back on your computer using your USB port. Whatever method you use, that's up to you. You can use Bluetooth. It's just one file you need to get onto and off your phone. Once the file is back on your machine, we have new points and lines and photos, whatever you captured. And the mobile project will give you the option of updating the source data. If you choose to update it, then it goes back to the source and you have completed what we call this data round trip from source to desktop to mobile, and then finally back to source. Now, that's about it for the theory behind it. I think we can jump into the software. So this is a new version. You'll see the UI is pretty similar. We've got a few new ribbons. And this is a typical workspace that you want to take out in the field. This data is from an antimony prospect in Australia. And we've got large road files. We got a DTM. We got some soil samples, some structural data. There's some geological polygons. There's an old geological map here as well. Some drone imagery, basically every type of data that you want to take into the field and want to record into. So we want to take all these fields to our mobile device, and we also want to record into some of them. So if we have a look at this one file I've got over here, Gannon Soil 2019, I'm just going to browse it quickly, and you'll see it's empty. So I set it up to capture data into. We've got our GPS, X, Y, and Z, lithology, color, bunch of different fields we want to record into. Now, first thing you want to do is to set up the tables so that they perform as efficiently as possible in the field. We want to capture into this Gannon soil file. We want to set up a streamlined capturing process. First thing we want to do is set up a few pick lists. Now, to the older users of Discover, you'll know this project ribbon over here, that's a new one. And everything that has to do with capturing will be situated in here. So when we go to our pick list manager, we can now either set up a new pick list. I've already set up a few for this specific project, such as soil color. Here we have a drop down and we have the associated colors here. And what's really nice is once you've done capturing in the field and you bring it back into Discover, all these colors will automatically give you a thematic map. We've also got a soil horizon one. Okay. So once you're done setting up these pick lists, you don't want to go and set up the table for capturing. So also not a new feature in Discover, the table validation tool. And we are going to select our Gannon Soil 2019. And this is where we set up all our rules. So if you have a look at the parameter column, we can assign a field to the GPS coordinates. Now, if the mobile device sees this GPS X, GPS Y, it will know that it needs to take a GPS reading and populate the column. Similarly, I have one here at the bottom, photo. So each record can have a photo associated with it. You don't necessarily just need one photo. You can just add more fields and add more photos. And then each record will also have a GPS date and time stamp onto it. And that will help once you check it back into your project so that it knows what is the latest copy. Then we have our lookup tables over here. So for lithology, color, and soil horizon, I've set up a few lookup tables. I have made them exclusive, therefore you can't manually type in anything else. And you can also set the map style for each one of them. Here we have a bunch of default values. So we know that all our sample types will be soil, sample method auger, the fraction, and the company. Another important one is the increment. So for our sample ID, each time we add a new record, it will go in increments of 1. And then there's also a number of validation rules that you can set up. I haven't set up any here, but for instance, you can set up minimum and maximum numeric values here. So for example, if you were to take dip readings, you will set a min of 0 and a max of 90 to restrict people from entering faulty readings. So that looks about right. Let's hit save there. Okay. Yes. All right, so now you can share that with someone, and if they open the table, all these validation rules will still apply. So we put all the data we want to export in one place. We've defined which files we want to record into, as well as validation rules. Now we go to our project ribbon, and then there's a new tool called Mobile Manager. And we hit that, and it opens up this. And I'm going to create a new project. Let's call it demo. And we specify iDirectory, similar to our Drillhole projects in Discover. And I'll just put this on the desktop. Let's put it in there in a new folder. And it lists all the files currently open in your workspace. We're going to choose all of them and we say next. I think I already have a file called that, so that's okay. The next step, it shows which files are read-only. So I only have 2 files that I want to capture data into. The rest I'm going to set to read-only. Now you can still interrogate them on your mobile device. You just won't be able to capture any data into it. You can also see all your validation rules if you click here. So there's my Gannon Swirl validations, and I'm happy with all of that. And once we can hit next again. Now the next step is to define a clipping region. Now you can either use your map window bounds or you can draw a polygon. And this is because you don't want to take all this, the whole Victoria state into the field. We just want to specify the area of interest. So I'm going to draw a region and it will clip out that data. So this will take a while. You can still capture data outside of this region. It won't restrict you from doing that. It just makes it easy to handle. And what it's doing now is it's clipping out the different topos, and it's also reprojecting everything to a common projection. Here it just gives me a validation status that those 2 files won't be read-only. That's fine. And data project has successfully been created. Okay, so there we got it. It's currently checked in. It's all in the same projection, so I'm going to open it up now. You need to close all table. Yes, I don't want to save the workspace. It's fine. So it will take whatever the base projection was of your base maps and reproject everything into that projection. Here we have now all the clipped data, and you'll see that it also adds a suffix to the names 9455. So that's the common projection it put it in. It's an Australian UTM projection. Okay, so if you're happy with that, what we'll do next is hit the checkout button. So we check out the project to either a cloud or somewhere on your desktop. Here it gives you a list of all the files. Now I'm not going to do this because I already checked out my project to my phone. But if you were to do this, just to give you a quick idea, it's going to save what is called a geo package file. So the one I've already checked out is on my desktop. This one over here. And this GPKG file is basically a zip folder of all the files that you have exported. And I just simply put it on my Dropbox and then import it back into my phone. So I'm going to get this app started over here so that I can mirror my screen of my phone on the desktop so you guys can see it. Just give me a sec. Okay, so that's my screen. Okay, there we go. Now, like I mentioned, this is freely available on the Google Play Store. Anyone can download it, and I'm gonna open it up. So currently I have a project open already. This is just the base satellite map. If you were to import the project for the first time, you'd simply go. So you can see just to talk about the screen, we've tried to keep it fairly simple. Leave the complexities for the desktop version. So on the right hand corner at the top, we got our settings. And if I wanted to import a new project, I'd click on import project over there. I saved it on this DCIM folder, and at the bottom there we have my GPKG folders, and you can simply import that. Okay. Now on the left, if I click that drop down, it gives me all the files listed in my project currently, and it is a layer control similar to other GIS systems, and I can switch these files on and off. So if we were to switch those on, you can see we've got some soil samples in Victoria State. Let me just zoom in there. Okay. And you can change the hierarchy of these layers to show some above other ones. Just to give you an idea, let's switch on the DTM here at the bottom. And this will be topo, so you can bring your grids in. We've got some structural measurements that were taken. There is geological polygons, and you can interrogate these. So if I click on one of them, it gives me a quick description of it, all the metadata included. We've got a all geological map here, and quality is fairly good. Like if your scan was good, the quality of this should be pretty good as well. Something like that. And then we also have a few soil surveys that were taken, and these can also be interrogated. So if I click on one of those, it gives me the sample ID, all the metadata that's associated with this. All right. There's also a drone image, really high quality drone image that was taken in the area. And you can see if I zoom into this and I just give it a bit more screen real estate, quality is fairly good. So you'll see at the bottom, at the top, it says no fix. That's why I'm situated in Africa and this data set is in Australia. But if I were to click this little radar at the top, you'll see that the target shows over there. And if I click on there, it will navigate to my current position, which is in Johannesburg. in our offices. We've also got a few different base maps that we can use here. Currently it's set on satellite, but we've also got the Google Road Maps. We've also got the terrain map, and then the satellite. Some of the other handy tools includes the ruler, so we can measure distances. So if I would select points over here, it shows me the segment length as well as the total length, something like that. And we've also got, like I mentioned earlier, the waypoint navigator. So if you have a specific soil sample that you want to navigate to, we hit this little button here, and let's say I've got a soil survey over there. We set a waypoint, and if I click start navigation, it's telling me it's about 10-minute walk, 500 meters. Okay, so let's go back to our Australian counterparts. Let's switch on the soil data there so I can find it. And let's say we want to capture some grab samples. So right now, there's two ways in which you can do it. You'll see the one here on my left in my layer control. The top one does not have a lock next to it. Now that's the table we set up earlier into which we want to digitize, right? So as soon as I hit the pencil, this little yellow plus button pops up at the bottom. Now we can use that. If we hit it again, you can either use the top button that will use our current GPS location, which will not really work in this instance, or we can use the bottom one, which will use the position of our crosshairs. So just give us a bit more real estate. You can walk with your handheld GPS in the field and also manually type in the GPS coordinates, of course. So let's say, for instance, we're walking next to this cliff and we want to sample it. We hit that button and then we need to populate this. So the first time you type in a sample ID, you'll have to do a bit of manual work. You'll have to give it its prefix. So in this instance, this was done by Jamieson Minerals. So we're going to hit JM001. We made increments of 1. So as soon as you type the next sample, it will automatically give it an ID of JM002. Here we have our GPS X and Y location. Because that image is georeferenced, we can hit the lithology. So in this instance, it was a sandstone. Color was light gray, and we collected it in Soil Horizon B. We can also add, you can take a photo or add a photo from your gallery if you wanted to. And it's going to give it a date and timestamp. So there we have it. There's our first point. And let's say we continue walking down this cliff and we want to take another sample over there. Same thing, we hit that, gives it the name, GPX, give it a lithology. Say this was a conglomerate and it was dark brown. And we took it from Soil Horizon A. You can also add a photo if you wanted to. Let me save that. So fairly straightforward, fairly easy. That's for points. We can also digitize some lines. So let's say, for instance, this Vic secondary road, we want a track point for that. Move this to the side. We can simply hit the cross. Again, it gives you the option of taking your current GPS location or manually typing in the nodes. So we can add a node, add node, add node. And once you're happy with it, you can commit line and you can enter the metadata in here. Okay, so fairly straightforward, easy to use. Um, there's also some settings that you can adjust in here. So under our settings, currently I've got my measurement of unit under meter. You can change that. The GPS interval, that's the polling interval. So every 5 seconds, it will take a new GPS location. So if you're walking and you want the pole to change every 5 seconds, you can adjust that as well. The waypoint buffer, that's when it will give you an alert when you within a 3 meter radius of your waypoint. And then the minimum distance for new node, that's if you're doing some track points and you want it to read a new point every 5 meters. You don't want it to read thousands of points while you're sitting in one place having lunch. So that's another setting you can set up. Okay, so that's about it. So let's say you're done with it, you're done capturing for the day, and you want to sync it back to your desktop. We can simply click on the setting button and we export either to the cloud, to your Dropbox folder, or export to internal storage. So what I did is I just exported it back to my phone and I saved it in a position where I can grab it from my computer again. Okay, so I'm just going to show you how that looks. Let me just close this up and we can go back to the desktop now. So we'll come back here to project and to our mobile manager. And I've got a folder here, Gannon's import, and you'll see it's currently checked in. Mine would say check out, would have to check it in automatically. So I'll open that up. Okay. And now if I browse my Gannon's 2019 soils file, we can see the two points that we added are in here, and we've got the photo saved under that location over there. So just to give you a quick idea, in our Gannon's import, we've got a folder over there that has our photos. And what's really neat is you can go to your mobile manager now, and here at the bottom left, it says source. So it will tell you all the source data that was used. If we say update source, it's going to show all the files that were changed. So here it gives us Gannon Soil 2019. Our primary key field is sample ID, and we also added a file, a line in Vic secondary roads. I don't want to update one. I'm just going to update the first one for now. So okay, and there it gives the two file points that we added. That's fine. We say update source tables finished. If I go and open that original file again, remember this one was called Gannon Soil clipped because it was just a project file, not a source file. It's going to open that workspace again, and if we browse that table, we'll see that it has been updated. Okay, so here's our original folder again. You see it's unclipped. We've got the big road files in. And here's my Gannon Soil 2019 folder. If I browse that, remember this folder was empty. There's our two files and it's updated. And we have completed the round trip of the data transfer, and all the data is nice and clean. We don't have millions of files, and those CSV later, they have names such as final 1, final 5. We've all been there. So it just keeps nice and smooth and streamlined the flow of the data. Okay, so just to end off, we have a team that's constantly working on this, and we want to make the app as good as possible. This is just the first version. So there's a lot more that we want to include. And we'll have an update of the app in about 3 to 4 months. In the next release, we will have thematic support. It has been one of the user requirements coming through. So to have color associated with your point files and such, and you want to see certain trends, you can take that out. You will be able to take structural measurements from your device, so capture the dip and strike using your mobile phone. You'll also be able to visualize structural symbols on the device. We'll have multi-resolution raster, multi-banded file support, such as Landsat imagery and such. The geofencing, let's say you have a bunch of tenement boundaries and you want an alarm to go off once you cross the border of your tenement. You can set something up like that. And then the XRF connectivity. The developers are currently speaking to the people at Olympus and Niton to get that up. You'll be able to take your XRF entries, so the element and attribute data, and visualize it as a thematic map as well. So really enhancing the interoperability. So this is planned for mid 2019, and then towards the end of the year, we are releasing what's called an outcrop mapping tool. So you can take a photo of an outcrop in the field, start annotating on it, and then take it into 3D. The iOS version was also due for release, and we're also going to have a look at how to integrate the data better with your enterprise data management tools, needed be Fusion or Acquire or one of those. Currently, something like the images are saved on folders and such, and we need to look at how to better incorporate it with SQL databases and such. Okay, so that seems to cover everything with regards to Discover Mobile. If we have any questions, please feel free to ask. I hope you guys got something out of it. Please feel free to go download the app, take it out to the field, test it out. Feel free to send me an email if you would like to know more. But I thank you guys for your time today. I don't see anyone raising hands here, so this is a strange system. But if you would like to know anything more, like I said, just email me. I can see our email listing, and I know most of the faces here. I know you guys have my email address. Thank you so much for your time, guys, and yes, go test out the app. Thank you so much.